Hey everyone, and welcome. Today, we're diving into a really fundamental shift in AI. We're moving from an AI that just knows stuff to an AI that actually does stuff. So we're talking about going way beyond simple chatbots and into the realm of autonomous agents that can tackle complex tasks all on their own.
I mean, just think about it for a second. What if your AI could take a goal you have and actually execute it? Not just give you the recipe, but actually help you cook the meal. That is the huge promise of what we call agentic AI. So, for example, you could ask it to put together a full report on some new technology. Now, instead of just dumping a list of links on you, it would go out, search on its own, synthesize insights from dozens of sources, and then draft a whole complete report. It's the difference between being handed a library card and being handed the finished essay.
And it's not just for research. Think about software development. You could give an agent a high-level goal for a new feature, and it would then go and write the code, run the tests, and, get this, even find and fix its own bugs, navigating a huge, complex codebase just like a human engineer would.
And what about all the tedious stuff we do every day? Imagine it booking a flight for you. I mean, really booking it, jumping between different airline websites, comparing all the prices, filling in all the forms, all without you having to click a single thing. That is a massive leap from where we are today.
All right, so how does all this magic actually happen? Well, first, we're going to explore what makes this kind of AI so different. Then we'll look at the engine room, how it learns to act. After that, we'll check out the new superpowers this unlocks. And finally, we'll talk about the big challenges still on the road ahead. Right, so that's the core idea. We're moving from a passive AI that just sits there and responds to a proactive one that actually takes the lead. The goal here is to build an agent that can size up a situation, come up with the plan, and then act on that plan over many, many steps to get a job done. But to build an AI that can actually do things, we need a totally different way of thinking, a whole paradigm shift in how we train it. We have to move beyond just showing it examples of good writing and start teaching it how to make good decisions. And this is where we get to the heart of it, Agentic Reinforcement Learning. Yeah, it's a bit of a mouthful, I know, but the idea behind it is actually pretty simple. We basically stop treating the language model like it's just a text generator. Instead, we start treating it like a brain, a policy that can make a whole sequence of decisions to navigate a world that's always changing.
You know, the best way to get this is with a simple analogy. A traditional language model, it's like a brilliant librarian. You ask a question, it finds the perfect answer, and that's that. But an agentic AI is way more like a master detective. It doesn't just answer one question, it follows a lead, it uses its tools, and it works the entire case from start to finish.
And if you look under the hood, this new approach changes absolutely everything. A traditional model gets one prompt, it spits out one chunk of text, and the episode is over. It gets one final score, good job or bad job. An agent, on the other hand, lives in a world that's constantly evolving. Its actions aren't just words. It can use tools, run code. And here's the kicker. It gets feedback for every single step it takes. This step-by-step reward is the secret sauce that lets it learn these incredibly complex, multi-stage tasks that a traditional model just can't even touch. So how in the world does an agent learn to be so intelligent? How does our detective get so good at cracking cases? Well, it's not by memorizing textbooks. It's by getting out there in the field and learning from raw experience. The engine powering all of this is called reinforcement learning. The best way to think about it is like teaching a dog a new trick. You don't write down a bunch of instructions for it, right? The dog tries something, and if it gets a little closer to what you want, like sitting, it gets a treat. That's positive feedback. If it does the wrong thing, it gets nothing. And over time, it figures out the right sequence of moves to get that reward.
And this all happens in a constant self-improving loop. First, the agent observes the world. Okay, what's going on? Second, it chooses an action. All right, what's my next move? Third, it gets a reward or a penalty. Did that work? Was that a good idea? And finally, and this is the most important part, it updates its own internal strategy so it can do better next time. This simple loop, repeated millions and millions of times, is how the agent masters these incredibly complex skills. Now, there isn't just one way to do this. There are a few different flavors of this learning. The most common one is called PPO, where the agent learns from a direct score, like getting an 8 out of 10. But sometimes giving a hard score is tough.
So we have other methods like DPO, which learns from simple human preferences. We just tell it, hey, response A was better than response B. It's a lot easier for us humans to give that kind of feedback. There are even newer methods, but they all share the same core idea. Learn from feedback to get better. Okay, so we put this AI through this really intense training. What's the big payoff? What do we get for all that endless trial and error? Well, it gets superpowers.
This whole learning process unlocks a brand new toolkit of abilities. The agent learns to actually plan and form long-term strategies. It learns how to use tools, like calling out to an API or running a piece of code. It develops a memory to keep track of what it's done. And it has the ability to self-improve by learning from its own mistakes. It can even perceive the world through things like images, not just text.
So if we go back to our detective analogy, these are the skills that take a rookie cop and turn them into a seasoned expert. Planning is how they map out the entire investigation. Tool use is their forensics lab. Memory makes sure they never ever forget a critical clue. And self-improvement is how they learn from a case that went cold to solve the next one even faster.
Now, this is all incredibly exciting, and it is. But the road to having truly general-purpose AI agents is still pretty long. And as these agents get more and more powerful and autonomous, we start to face some really important new challenges.
The first big hurdle is trustworthiness. How do we make sure these agents are secure and reliable? That they don't just make stuff up, or worse, just agree with us to be pleasing? That's a problem called sycophancy. Then there's the sheer scale of it all. Running millions of these simulations takes an insane amount of computing power. And finally, we need better training grounds. To build smarter agents, we have to create more complex, more realistic digital worlds for them to learn and grow in.
And that last point is absolutely critical. An agent can only get as smart as the world it learns in. I mean, think about it. A detective who only ever solves simple cases in a small town is not going to have the skills to take on a complex international conspiracy. We have to build a richer, more challenging digital world if we want to unlock that next level of intelligence.
This all leaves us with one final, really big question to think about. We're building AI that can act on its own. The technology is moving at a breakneck speed. The biggest question for all of us is this. As these agents get better and better at acting in our world, how do we get better at guiding them? Guiding them to act wisely, safely, and ultimately for the benefit of everyone.